Right. Okay. So I'm Lekan Popoola from the University of Cambridge. I'm an atmospheric scientist with a particular interest in air quality and greenhouse gas and climate change. And I tend to approach this from a measurement point of view using sensors and sensor technology, sensor network. Currently, I'm part of the New Breed London Consortium, helping to deliver some of the technical outputs of the project. And today, I'll be talking to you about revealing some of the hidden stories behind air quality monitoring, particularly focusing on PM2.5 using data from the current Breed London. Now, this is the title I've been given by Maddie, but this whole talk is based around an article that's written that you can find on the Breed London website, which is Where is London, London's particulate pollution coming from? And here's the link for those that haven't had the opportunity to actually read the article. So, but today I'll try and talk through the main content of the article. So here is just a brief outline of my talk. I'll briefly touch on the conventional representation of air quality data, how this is being done and is currently being done. Then I'll briefly discuss this new analysis approach that we can use to actually get more out of the air quality data sets, particularly using high resolution data sets. And this approach is, we tend to call it source apportionment, where we try and partition the signal you're monitoring into what we call a local and non-local component. And I would finish up with just a recap on what we've discussed. And again, I'm plugging in here the link to the article. So if you really want to read more about this work, feel free to follow that link and read more about the article. So I know there are a lot of people from the local authority here, and what I'm showing here is just the conventional way or the traditional way that we tend to look at air quality data. So quite often it's often presented as hourly averages. I mean, we've got some reg equation where you have it as 15-minute averages, but generally speaking, it's presented as hourly averages. So what I'm doing here is I'm taking two sites from the current Breed London network, which are categorized as open background shown in green and a roadside site, which is shown in orange. And when you look at that data set for PM2.5 in as hourly average, this is data that over around 2-week period. And what you see is, I mean, there are clearly, regions where they track each other, they see departure, they track each other. Now that's the kind of information you get, and you use this generally to, and the reason why quite often traditionally this has been represented as hourly average is to try and evaluate compliance to air quality guidelines and directive to try and see if this has been met. And it's a good metric or good way of assessing overall exposure to outdoor air pollution. But the question we are trying to do, I mean, well, what we're trying to look at is, can we actually get more insights? Is this the best we can do with the current data sets that we have? And that's what this whole talk would focus around. So if we step back, so rather than look at hourly averages, if we go back and look at the actual measurement that is being used to deliver that hourly average I showed in my previous slide, this is what the data looks like. So what I'm showing now is exactly the same two sites. And this is now presented at a higher time resolution. So you have this as 1-minute averages. And now you can begin to see distinct pollution pattern between the two sites. And if I actually home in on here, so you can see here in the cyan, there are regions where we can actually see the roadside sites where we see this large local variability that would be linked to localized sources. And there are other regions between the two sites where it seems like the signal is very similar. So like this period here, you could see you can barely make, there's barely any difference between what we classify as an urban background, which tends to be a clean site. Well, when I say clean site, I mean a site without very localized emission, versus a roadside site where you'd expect to see impact of local emission. So the challenge is, given this complexity in the pattern, of pollution between these two sites, out of the 100 network that we have, is there a possibility to isolate these signals where you'd have the impact of local emission versus what seems to be a common signal between the two measurements at these sites? So, and that's what this next slide is. I'm trying to talk through how we've gone about doing the analysis. So this is an animation, just taking one site and walking you through how we can get additional information from there. So in this first panel here, I'm showing two time resolution data sets. So the first one is the 1 minute measurement, which is shown in the cyan, and the hourly average of that same signal is now shown in black. So essentially what you would be getting from the traditional way of looking at air quality data would be the black line here. So what we can do then is, if you take that high resolution data set, you can actually work out what is the minimum reading over a defined time window. And that's what we are showing here as the local, obviously the non-local signal. So invariably, this is a measure of a pollution that would be common to all these sites across London. So if you imagine London as just a city that is not developed, and well, if you go to like a large area, you would get variability in the PM due to air moving into that domain. And that's what we are trying to capture by this red signal here. And anything above that would be representation of what's happening in your study area. So we can manage, because we are making high time resolution measurements, we can work out this lower reading over a defined time window. In this case, you can do it over an hour, as we formulated it within our analysis for Bray London. So if I now average this signal, so that's what you get. So again, I mean, just to remind you that the black line here is still what you would represent as the hourly average signal. But because we have access to the higher time resolution, we could pull out this red line. And this is how we extract additional information. And so the difference, or what's shown in this shaded region here, would be the local fraction. So essentially, that would be emissions in close proximity to your monitoring site. And you can actually see there are periods where that fraction is huge. There are periods where the fraction is small. So so I would say during this region here, you've got more local activity, which is evident here. You can see more spikes. Whereas this region here, you barely see anything. And this is actually close to the early hours of the morning. So you'd expect, everyone to be asleep at that point. So there's very little local contribution there. So what you essentially do is you'd represent the black as your non-local and the residual here as your local fraction. So essentially, the last bit is, if you take out or subtract the red line from the black line, you get this signal here, this shaded region. And bear in mind, the scale here is about a third of this. So this is going up to 30 microgram. This is now 10 microgram. So now you begin to see what's happening locally, which should be driven by activities at this site. So this is done just for one site, and you can repeat this process for as many stations as you have within your network. So now I'll pivot back to the two sites that we've been looking at, the green and the clean and the background and the roadside site again. So taking that technique that I've just talked you through in my previous slide, so let's now look at the signal of this non-local signal. So what's been wafted in to London. So if we take our measurements and we do the analysis I just described previously, and you now look at it for the two sites, now what you get is your non-local component looks very similar across all the sites. And the key thing here is that this is often associated with long-range transport. So that means that's pollution being wafted in, and it's coming from sources upwind. And the other key thing to take away is that this non-local component of your total signal is often affected by meteorology. So you could have regions where, depending on where the air is coming from, it could be coming from, way up from the north or from the Atlantic or from Europe, depending on how fast the wind is moving. So it affects it. So this signal is often affected by meteorology, and these are some of the parameters that you need to consider. So the stability, the air mass origin, and also the wind speed. And the key thing about here for policy is this component will be less impacted by the local policy intervention, because these are a fraction of the PM, in this case, that you're monitoring that would be coming in from regions outside your study area. So now let's look at the other components. This is now the local fraction, which is what we are actually more interested in. And now you can begin to see, the classification of those two sites coming into play here, because we have a site called a background site and one called a roadside site. And for the background site, the local component barely goes above 1 microgram or 2 microgram, give or take. So on average here, for the background site, the average background signal here over this period is about 1.1 microgram per cubic meter. Whereas for the roadside site, this on average over this about 3 weeks, 2.5 weeks window, it's about 4 microgram. But the good thing is you can begin to see this, very localized pollution pattern. And these would be often impacted by what's happening in vicinity of the sites you're monitoring. So for this roadside site, it could be due to impact of local roads, industry, residents, etc. And the other thing is this signal can be thought of as being less impacted by weather, because you've taken out the general weather impact in the long term, in the non-background signal. So you could classify or think of this signal as almost like a de-weathered data set. And the final takeaway or key thing here is that these localized mitigations and policies are more effective against this. Obviously, these are being driven by emissions happening locally in the vicinity of your measurements. Then by putting it in place, like Natalie was talking about, having in London, having a ban on use of wood stove. I'm not saying that's where this pollution is coming from, but if you have that at a site where you're seeing impact of local wood stove on your PM reading, that kind of policy can easily be more effective, because you're taking out that local emission source. So essentially, a localized mitigation and policy will be more effective against this fraction of data sets. So to recap and part of the take home. So if you have a measurement that you're making of air quality, in this case, 1 minute data sets, and I know most of the reference sites actually start on measuring measurements, at least in the case of some of the gas species at higher time resolution, but again, by convention, they often report as hourly. So this data set is often presented this way. And if you look at these, your eyes is almost drawn to the similarity, although there are some differences here, which we can get that difference is more enhanced by the analysis, this additional analysis you're talking about. So the conventional approach, or the traditional approach, is to present the data in this form. But are there untapped opportunities? Yes, there is, because what we could do is you could exploit the fact that at least one of the ways of looking at this is to do a scale separation on these fast measurements to gain further insights. And when you do that, you can actually split this signal into two fractions. So you get the local, which is due to close proximity emissions, and the non-local, which seems to dominate, at least in the case of PM, dominates most of the signal, and which is often often similar between multiple sites. And this is often associated to long-range transport. And you need policies that are transnational, transboundary to be able to mitigate against this, whereas very localized policy would help you target impact linked to this localized emission. And again, all these detailed, this is part of an article that we've written as part of the Breed London, and you can find that there. And thank you for listening, and I'll take any questions.